everyone, my name is Kayla and my talk is about the Pacific Garbage Gyre. This is an overview of the topics related to the garbage gyre that we will discuss. We'll talk about the wind and sea currents of the gyre and how it contributes to garbage patches accumulation. Then we'll talk about how the garbage in the gyre affects the marine wildlife and humans. And lastly, I will discuss the efforts that have been made to remove the waste. But before we get into all that, what is the Pacific Garbage Gyre? Also known as the Pacific Garbage Patch, it is a patch of debris spanning over 1.6 million square kilometers, which is twice the size of Texas, and it's located in the North Pacific Garbage Gyre. There are two zones of debris in the Pacific Gyre, one located between the west coast of North America and Hawaii, and the other between Hawaii and Japan. The debris in the garbage patch is categorized into four size classes: microplastics, mesoplastics, macroplastics, and megaplastics. While 94% of the debris count is made up of microplastics, larger plastics account for the majority of the patch's mass. It's estimated that it contains 1.8 trillion pieces of plastic, weighing almost 100,000 tons. While there are many identifiable floating items in the gyre, macroplastics such as cigarette butts, plastic bags, food containers, laundry baskets, plastic bottles, medical waste, fishing gear, and more. Most of the plastic is the size of pepper flakes or smaller, broken down by the sun and waves over the years. The pollution in the ocean stems from discarded fishing gear, ocean littering, and poor waste management systems, especially in the coastal regions where coastal waste is swept up by the ocean. The waste is further carried and accumulated through the Pacific's current system. The graphic to the right shows an estimate of each country's contribution to plastic waste in the ocean. The graphic shows how North America and Asia have high rates of pollution, which are the nearest coastal regions to the North Pacific Gyre. The waste is trapped by the Pacific Subtropical Gyre, a system of ocean currents that form a massive rotating vortex. The gyre covers an area of about 20 million square kilometers, making it a key player in the concentration of debris. As these currents circulate, they draw in plastics and other materials which can linger in the ocean for decades due to their non-biodegradable nature. The Pacific has two major gyres, the North Pacific Gyre and the South Pacific Gyre, which are vast circular ocean currents that trap marine debris. We will be focusing on the North Pacific Subtropical Gyre, as that is where the garbage patch is located. The North Pacific Subtropical Gyre plays a crucial role in the accumulation of debris. As the currents circulate, they trap floating plastic and other materials, preventing it from dispersing and leading to the gradual buildup of patch over time. By concentrating waste, the gyre disrupts food chains and introduces harmful chemicals into the ocean environment, which we will talk about later. As you can see from the graphic, there are two zones of the North Pacific Gyre on the east and west, which is where the currents continuously pull in waste from the coastal and oceanic sources, making cleanup difficult and allowing plastics to break down into harmful microplastics that persist in the marine ecosystem. These gyres are formed by surface currents that are primarily a combination of Ekman currents driven by local wind and geostrophic currents maintained by the balance between sea levels and gradients, and the Coriolis force. The interaction between Pacific gyres and Ekman wind dynamics drives surface waters into a central convergence zone between the east and west gyres, creating a bulge of water and trapping floating debris. This process leads to the accumulation of plastics and other wastes in the middle of gyres. When winds blow over the surface, they create friction, causing surface water to move in the northern hemisphere. This water is deflected to the right of the wind direction due to the Coriolis effect. In the Pacific Ocean, large-scale wind patterns such as the trade winds and westerlies drive currents that form the North Pacific and South Pacific gyres. Because of Ekman transport, these currents push surface waters inward towards the center of the gyres, creating a slight bulge in the water. Now for the garbage gyre's effect on wildlife. Due to its size and concentration, marine animals like fish, sea turtles, dolphins, and whales are at risk of getting trapped in the patch's debris, which can lead to injury, suffocation, and death. It's estimated that thousands of marine animals die each year due to entanglement in the garbage patch. Marine creatures can also mistake small plastic particles for food. Sea turtles, for instance, confuse plastic bags with jellyfish, which is one of their favorite meals. Creatures ingesting these plastics can lead to malnutrition, blockages in the digestive system, and even starvation, as the animals consume plastic instead of real food. The patch also causes disturbances in the food chain as microplastics, which make up a significant portion of the garbage patch and are ingested by plankton and other small organisms at the base of the food web. As these plastics move up the food chain, they accumulate in larger predators, including fish that are consumed by humans. This bioaccumulation can lead to the presence of toxic chemicals in seafood, posing health risks to humans. Now for the garbage patch's effect on humans. First, toxic chemical exposure. The plastics in the garbage patch contain harmful chemicals like BPA and phthalates, which leach into the water and absorbed by marine life. When humans consume seafood contaminated with these chemicals, they may be exposed to toxins that have been linked to health issues such as hormonal imbalances, reproductive problems, and even cancer. The economic consequences. The garbage patch also has economic implications, particularly for the fishing and tourism industries. Contaminated fish stocks, polluted beaches, and need for cleanup efforts are costly and contributes to the economic burden of ocean pollution. The garbage patch also impacts on food security because as marine life is affected by the garbage patch, there is a potential decline in fish populations, which can lead to reduced availability of seafood. This not only impacts food security, but it can also affect livelihoods, particularly in communities that rely heavily on fishing. The most well-known cleanup effort for the garbage patch is conducted by the Dutch nonprofit Ocean Cleanup, which was founded in 2013 and aims to clean up 90% of floating ocean plastic by 2040. The ocean cleanup system consists of a large floating mesh barrier that captures debris as it moves with the currents. The circulating currents in the garbage patch move the plastic around, creating natural but variable hotspots of higher concentration. The organization uses computational modeling to predict where these hotspots are and place their cleanup systems in these areas. The design of the mesh allows for small marine animals like plankton to pass through, as well as provides escape hatches along the barrier to allow for larger marine animals to swim out safely. Once full, the collected plastic is brought back to shore for recycling. The ocean cleanup has already removed thousands of kilograms of plastic from the garbage patch, and ongoing efforts continue to achieve their 2040 goal. Some other approaches to the ocean cleanup are ghost gear removal initiatives, since discarding fish gear makes 46% of the garbage patch's total mass. Organizations have launched efforts to remove these dangerous materials. Groups like Ghost Diving and Healthy Seas organize dives and retrieval missions to recover abandoned nets from the ocean, preventing further harm to marine life. Additionally, some fisheries are adopting practices to reduce the loss of gear, such as using biodegradable materials and improving tracking systems. The Seabrin project is another innovative approach to ocean cleanup, focusing on the capturing floating debris in marinas, ports, and other coastal areas before it can reach the open ocean. Sea bins are floating garbage bins that suck in water from the surface, trapping plastic and other debris inside a catch bag. While not specifically targeting the garbage patch, the Sea Bin project helps to prevent additional waste from entering the patch by addressing pollution at its source. Now to summarize what we've learned. The gyres in the Pacific are large circulating currents that are accumulating and trapping large amounts of debris, forming the Pacific garbage patch. This debris is toxic to both marine life and humans as it accumulates in the ocean and our food. While efforts to reduce and clean up the patch are making progress, there is still tons of waste left to go. that was my talk. Thank you for listening. I hope you enjoyed. And here is a list of the sources that I have.